Alrighty, let's take a look at this question. So we're asked to find the equation of this graph, of this parabola, and yes, we want to start with vertex form. Now, the problem is we don't exactly have the vertex. We know the x value because they told us the axis of symmetry is x equals -5, and therefore we know the x-coordinate, which is really our p-value in our vertex form. So we know one thing, so we might as well write our equation then with that one thing in there. So x minus -5 would be x plus 5 squared, and then plus q. We don't know a in front of the brackets. We do not know q. So we're kind of stopped at that point, but they did give us a couple points. And anytime they give you a point on a graph, you can sub that point in for x and y and solve for whatever you need to. So we're going to do that. We're going to start with -9 and 9. So 9 in for y, -9 in for x. And we're going to simplify this. So 9 equals a, okay, so -9 plus 5 is -4. -4 squared is 16. So 16 times a would be 16a, and then plus q. Now, we're kind of stopped at that point because a and q are two unknowns. We're not going to be able to solve for anything right now because there's two unknowns in there. So they did give us another point, 1, 24. So this one, and now we're going to sub in 124 into that original equation that had the p-value in. So we're going to have y equals, sorry, not y equals, we're subbing in for y. 24 equals a bracket 1 minus, plus 5 squared plus q. All right, and then we're going to simplify like we did the other one. 1 plus 5 is going to be 6. 6 squared is 36. So we'll have 36a plus q equals 24. All right, now we have to slip back into what we covered in grade 10, which was solving a system of equations. We have two unknowns, two equations, so we can either solve by substitution or elimination. I'm leaning towards elimination because the q's both have a coefficient of 1. So if I write the first equation underneath the second equation, lining things up, if I subtract that second equation, the q's will equal 0, which will eliminate the q's, hence the name elimination. So 24 minus 9 is going to be 15. 36a minus 16a is going to be 20a. And then we are going to divide by 20 now that we only have a in the equation. And if we divide both sides by 20, we'll get a equals 3/4. All right, now once we have a, we just sub back into one of those equations we just had. Let's go back into that first one. 9 equals 16. Throw your a in. 3/4 plus q. And 16 times 3/4, 4 goes into 16. 4 times 3 is 12. Plus q, okay? And then isolate q by subtracting by 12, when we would get -3 equals q. So now we can actually write our equation. So we go back up to this one because we want to still have x and y in our equation because that's how we make our actual parabola shape on the graph. So we have y equals, put in your a, 3/4 x plus 5 squared, and then our q minus 3. And to check that, to make sure that this equation matches that graph that we were given, you would put it into your calculator in y1 and just check out a few points by going trace and then type in like -9 to make sure you get y equals 9, type in -5 to make sure you get a q value of, or a y value of -3, and then lastly that 1.1 should be a y value of 24. So that will confirm if you've got the right equation or not, which we do. Okay, so now they ask find algebraically the x and y intercepts. Let's start with the y-intercept. That's the easiest, but essentially whenever you hear intercepts, something is going to equal 0, because if you think about a point, say on the y-axis, the one thing we do know is the x-coordinate would have to be 0. And for an x-intercept, the y-coordinate would have to be 0. So that's how we're going to solve or find them algebraically. So let's start with a y-intercept, and we're going to let x equal 0. Now, we can use, well, we have to use the equation that we found in part A because we didn't have any other equation. And we replace x with 0 in that equation, and then you can totally put that in your calculator and get 15.75. Now we could change that to a fraction, but it's not a bad decimal. It ends after the 5, and yeah, so, and let's look at our graph to see if that seems reasonable. And it does look like it's kind of in that area. That's why you don't want to guess and just say, yeah, it looks like 16, we'll go with 16. But, and then we can write that as coordinates, 0, 15.75. All right, now let's find the x-intercepts, which means we're going to set y equal to 0, which is a little bit more algebraic. We wouldn't just put this in the calculator. And what we're going to have to do is basically isolate our x. So first step we're going to do is add 3 to the other side. And then we are going to, so essentially when you're solving for something like this, you want to reverse BEDMAS. If you only see x in the one position, you can isolate it by just peeling stuff away, reversing BEDMAS. So get rid of adding, subtracting. The -3 goes first, then multiplying and dividing. So now we're going to divide by 3/4. Or if you want, you can think of that as multiplying by 4 first to get 12, and then divided by 3 to then get back to 4 again. All right, now that we have that, we're going to get rid of the exponent, the square, by square rooting both sides. Now, just remember when you square root both sides, you actually get 2 answers. 2 when squared gives you 4, so that would be one of our equations. 2 equals x plus 5. Or -2 when you square it, you get 4, so that would give us our other equation. And then we solve for x for each of those by subtracting on 5 on both sides. We get -3 equals x for one, and -2 minus 5 is going to be -7 equals x for the other one. And if you look at your graph, that looks pretty good, actually. It does look like they're going through those. But again, don't go by looks. You always want to do it algebraically. So -3, 0 and -7, 0 would be your x-intercepts. Alrighty, now for domain and range, that's easy peasy. We look at the graph, don't have to do anything algebraically. So domain, since the graph goes forever to the left and forever to the right, our domain would be all real numbers. That would be that in set builder notation, or if you do interval notation, it would be round bracket, -infinity, comma, infinity, round bracket. All right, now range, looks like we have a low point, right? So y would have to be everything above that, and that would have been our q value of our vertex, which was -3. So y is greater than or equal to -3, and then comma yer, or if you're doing it in interval notation, the lowest value would be -3, and it does equal that, so square bracket, and then comma, it goes forever up, so infinity, round bracket. All right, there you go. I hope that helps.